What would you do if you design your application in a way that make your code more reusable, maintainable, and scalable? Of course, you would want it to document somewhere so that you could use that as a template again and again in the future. And when we create a template, that template helps not just us, but it become a reference for everyone around for commonly occurring problems. So design patterns are those time-tested, proven solutions to specific problems that arise during software development, and they provide a template for solving similar problems in the future. Since these patterns are there for several years, now they also provide a common vocabulary for designer, architects, and developers in the process of software development. They help in communicating the intent more clearly, and that makes it easier to understand and maintain the code. So now you may ask, why do we need design patterns? So the one line answer is that you don't need them at all. But if you believe in following the best practices, building better software, design applications that are flexible, maintainable, and scalable, then you must try to apply these best practices that are the results of the decades of experience of people in your industry. After all, like design principles, design patterns promote some best practices such as separating concerns, minimizing coupling between components, and using abstractions to make code more flexible and adaptable for changing environments, for changing requirements. By adhering to these best practices, software developers can create code that is more modular, easier to test, and less prone to errors. So, anyone interested to do better and effective programming must have some idea and understanding about some frequently used design patterns. There are many design patterns, and they are broadly categorized into the three categories based on their purpose: creational, structural, and behavioral. Articulated first in the classic design patterns, elements of reusable object oriented software book, written by Eric Gama, Richard Hell, Rolf Johnson, and John Wilsidis, the Gang of Four software practitioners. The foreword of the book is written by Grady Booch, the man who crafted UML as well. But some of the most popular ones and the most frequently used ones are these. In the creational patterns category, we have the singleton pattern, a pattern that ensures that only one instance of a class is created and then provides a global point of access to that instance. Then we have factory pattern, a pattern which provides an interface for creating objects but allows subclasses to decide which classes to instantiate. And there's abstract factory, which provides an interface for creating families of related or dependent objects without specifying their concrete classes. Under the structural patterns category, the most commonly used are adapter pattern, a pattern which allow two incompatible interfaces to work together by wrapping an object and exposing a standard interface. Another popular one is decorator pattern, a pattern which adds functionality to an object dynamically by wrapping it with another object. And then we have the facet pattern as well, which provides a unified interface to a set of interfaces in a subsystem. Similarly, under the behavioral patterns category, the most popular one is the observer pattern. This pattern defines a one to many dependency between objects so that when one object changes its state, all its dependents are notified and updated automatically. Next, we have command pattern, a pattern which encapsulates a request as an object, thereby allowing you to parameterize clients with different request, queue or log request, and support undoable operations. And we have the strategy pattern as well. A pattern which defines a family of algorithms, encapsulates each one, and makes them interchangeable. Now, a natural question can come to your mind that what's the difference between design patterns and design principles? Well, we can say that the difference is in the name itself. Design principles are the principles, or we can say a set of high level guidelines that help software designers to make decisions about the overall structure and organization of their code. So they are more general than design patterns, and they provide a broader set of guidelines for designing software systems. While design patterns are some reusable solutions to commonly occurring problems in the software design. They are the templates that help in writing code that is more modular, reusable, and maintainable. So, design patterns provide specific solutions to common problems, while design principles provide general guidelines for designing software systems. In other words, design patterns are implementation level solutions to specific problems, while design principles are strategic level guidelines for designing the software systems. In practice, we use both design patterns and design principles as they are the important tools for software design and development, and they ultimately serve a common purpose that is well designed, maintainable, and scalable software system. Solid design principles we have already covered in the previous videos. Now we will explore some of these popular design patterns from the next part.